Okay, so we are going to talk about the Taylor polynomial today. So what is Taylor polynomial? So when do we need to use the Taylor polynomial? Is when you find there is a function and it is like really difficult to calculate. So you will use Taylor polynomial to approximate the value of it. And also, what is the Miracle-Linked series? It's actually also Taylor polynomial. And why it is called different name is because it specifically point out that the center of it need to be at the point of x equals 0, which actually simplify the whole functions a lot. So that's why people use x 0 as the center point. Okay, so we all know in the calculus 1, we learn how to calculate the derivative. And it's not very difficult that we use this very simple concept to understand what is a Taylor polynomial. So in calculus 1, you all know if I want to know the tangent line, which is the blue one here, the tangent line at x equals to a, and then we took the derivative of it, and then we wrote it down because this line going through the f of a and and x equals to a, which will be looking like this. And if you kind of move it around, and this is your tangent line, which will be looking like this. So the basic concept here is you try to use the derivative, the tangent line of it, to approximate your actual function. So this is the core concept of the Taylor polynomial. Okay, so with this in mind, then we could continue. So for example, let's say your function is f of x, and that's assuming it is similar to the p of x, and that's assuming it's looking like a polynomial, so it's to the power of n. So it will be looking like this. Your a0 plus a1, and then x minus a. Yeah, at the center point of a, I forgot to mention. And then plus a2, x minus a to the power of 2, all the way to a sub n times x minus n, x minus a to the power of n. So let's see what will happen if we took the derivative n times. It will be, all this will disappear, and we will only have an times x minus a to the power of n, and this one's derivative, which we can see over here. It will be n factorial times an times x minus a, right? So if we move it around, your an will be, this one should disappear. So your an will be your p sub n to the power of n of x divided by n exclamation. Which this one I should write it differently. Oh, that's the other thing. Yeah, I will talk about it later. So as long as we all know the category here, then we can apply to the original function and then approximate f of x. So your p sub n of x function will be looking like this. Let's put it in. Will be your f of a plus your f of a derivative of 1 factorial times x minus a, and then plus your f of a, and we took the derivative 2 times, and then x times x minus a divided by 2 factorial, and all the way to the n factorial, and on top will be your f of a and we took the derivative n times, and then we times x minus a. So it will be looking like this. So what is miracle that we're talking about? It was assuming your x is expanding at the 0 point, which your a will be equals to 0 in this case. So it will be your f of 0 plus your f of 0's derivative times x divided by 1 factorial plus your 2 times derivative and then times x to the power of 2 divided by 2 factorial, and all the way to the f. We took derivative to the n of, why is this looking like theta? It's 0. 0 and then times x to the power of 0 divided by n factorial. Okay, so now we can see it's going to make this function very simple because your a equals to 0, which here will only have your x. So this is the concept of Taylor polynomial and the recurring series.